This is a particle podcast. WA Science told different. Powered by SciTech.
Please Look Up is recorded at SciTech on Wajak Noongar land. Good evening, everybody. My name is Leon.
And I'm Amanda.
And welcome to Please Look Up, your monthly deep dive into all things space news. And this month we're talking about the night sky and the space news for August.
So, Leon, what's up in the sky this month?
Well, before we do that, firstly, welcome back, Amanda. It's been a while since we've had you on this podcast.
It has. Beth took my job. That's all right. I'm back while she's overseas in the UK.
Ah, right. Well, you've taken her job, so
Yeah, no.
it all makes sense. So this month, the night sky is all about the constellations we can see, because as we covered last month in the podcast, and it's still kind of relevant, the Milky Way is really high up above during winter, and so that makes this the best time of year.
Yeah, except all the clouds. That gets in the way.
Well, yeah, exactly.
But when it's clear.
You've got to try and pick the clear nights. So, yeah, it's the luck of the draw there. I mean, maybe not on the day of this recording, which is it was raining all night last night, but who knows. But yes, the two real bright constellations you can keep a lookout for right in the middle of the Milky Way. Well, you can tell me, Amanda, what are the two obvious ones right in the middle?
Two obvious ones. Probably Scorpius and Sagittarius, maybe. I find it very difficult to see, but I can see a teapot in there, so
yes,
that's worth looking out for.
Yeah, you're right. Those are the ones I was thinking of. Yes, I agree. The complete Sagittarius is a mess.
Yes.
You need to have been on something wicked to have seen a centaur out of that pattern of
As
stuff.
many children tell me in the planetarium, they are not impressed with us calling that a centaur. But a teapot in the centre, they can get behind a bit more.
Yeah, exactly. So in case you're wondering what we're talking about, when you connect the lines as in the official drawings of Sagittarius, it just looks like a scribble, and it's supposed to be a centaur, half horse, half human. But when you look at it, you're like, nah, mate, that is not a centaur. However, if you sort of trim down some of the stars, just snip off some of the ones, do we really need that one? You can actually make out a teapot pattern of stars, and that's much more obvious.
And much cooler because the spout of that teapot points you right to the centre of the Milky Way galaxy. So you can stand there and be like, that's the centre of the galaxy, even though you don't technically see the centre of the galaxy, but you can point it out. It's a cool party trick.
Yeah, it is. It is a cool party trick. Yeah, you're right. And the centre, of course, is where the supermassive black hole is. Again, you can't see that, but it is there.
You know where it is.
Yeah, there you go. So yes, very cool party trick. And then just next to it is Scorpius, which is your sort of hook-shaped pattern of stars, the tail of the scorpion. And in the middle is the red heart of the scorpion, the red star Antares, and that guides the way, or as it sometimes, as you like to call it, Amanda,
the heart of Scorpius.
The heart of Scorpius.
I think it's more poetic.
Yes. However, if you turn to the north as well, so you're no longer looking directly at the Milky Way, there's a few more constellations you can see. They're quite low on the horizon, but they're quite. There's a couple of bright stars that can help you guide the way. There's Hercules out of sort of legend, and the Hercules constellation is quite faint, but there's sort of a square-shaped pattern of stars. It's very low on the horizon because it is more associated with the northern hemisphere. And then there is Virgo that many people have heard of as well. Virgo for the symbol of fertility or whatever you want to call it. But Virgo's identified by a very bright star called Spica, spelled S-P-I-C-A, so Spica maybe. Maybe. You realise when you nod.
I'm nodding. I don't know what to add. I didn't even know Hercules was up. That's in the north. I don't look north.
Ah, okay.
Then I'd have to turn around. It's very hard.
Given that you don't look north, the other cool thing about the Milky Way being really high up during winter is the Southern Cross is really high up, because the Southern Cross is it lies along the Milky Way. So if you're facing south and look really high up and find the Southern Cross, then you just turn around and look a bit lower and find Hercules.
I'll have to try that next time.
Now, there is, of course, a couple of planets you can see. And the planets this month, you can look out to the west and you'll see Venus in the western sky.
That's it, because I feel like there haven't been planets for a while.
Yeah.
Mercury, sort of.
Yeah.
Not a great one to look at anyway.
No, it doesn't really try very hard. No. But yeah, Venus is definitely there in the west now for about an hour and a half after sunset. Or it's kind of visible before sunset. You don't need to wait until it's completely dark. And you'll see it there, and you see why it gets its name of the evening star. And also Saturn is rising at a reasonable time at 9 o'clock. You'll be able to see it in the east.
Oh, I'm even still up at that time. That is quite reasonable.
Yeah. Oh, you're one of those monsters that gets up in the morning, aren't you?
Yes. Usually you say reasonable, it's 11 p.m. and I'm like, no, I'm in bed then. That's not reasonable.
All reasonable people stay up and look at the stars. That's reasonable. Normal people don't go to bed at 9 o'clock in the evening.
Stay out just enough to look at Saturn and then go to bed.
And then go to bed. So that's mainly the night sky this month. If you are out, if you're one of those morning people, you can go out and look again at Mars and Jupiter. They are in the east before sun rises. And the day that I suggest you go out is probably either the 14th or the 15th of August. And the reason for that is Jupiter is overtaking Mars in the sky at the moment. Well, it's kind of the other way around. Mars is doing some weird stuff and Jupiter's just kind of trudging along. And anyway, long story short, they're really, really close together in the sky on the 14th and the 15th, like less than your pinky fingernail apart.
That does sound cool, but I remember Jupiter and Saturn being very close together and we all got told it was like a Christmas star, and then I looked at them and they were just two dots sort of close together in the sky. It wasn't that interesting, so I'm probably not going to be tricked into looking at planets again just because they're sort of near each other in the sky. It's actually not. Sorry.
I think it's cool.
That was really disappointing last time that happened. We went to the beach to look at it. There were a lot of people there and we all went, oh, look at them.
I remember that. Was that like 2020 or something?
It was, yeah. And then people had telescopes set up and we were just...
Yeah, I thought it was cool.
No, Steph and I went, another planetarium presenter, and then we ended up just going to Macca's instead. Like, oh, this is better.
Well, I recommend, I might even have to do it myself, getting up at 6 o'clock.
6 a.m.
I might. On the 14th or the 15th of August. And yeah, look to the east, in the east. And obviously Mars is reddish, but Jupiter is by far the brightest out of the two. So you'll see a very bright Jupiter, and then sort of just to the bottom left of it, you'll see Mars looking kind of reddish and kind of faint. But it is there.
Next to each other.
Yeah, next to each other. It is. It's very cool. So that's in the night sky this month, but that does lead us nicely into the constellation of the month.
Leon, what have you chosen for the constellation of the month this month?
Well, it is one of those constellations in the north. So I mentioned that there is Hercules and Virgo, but in between them there is one more, one that I want to draw your attention to, and it's called Corona Borealis.
Yeah, again, really exposing how little I look at the north sky. That when you sent me this and said we're talking about Corona Borealis, I went, not Corona Australis? I didn't know there was equivalent. Oh. Which, fun fact, there is a Corona Australis as well.
There you go.
Which means the southern crown.
Mm-hmm. So Corona Borealis.
This would be the northern star. The northern crown.
Yeah, it is the northern crown. You've just launched right into the Latin there.
Yeah. Borealis, meaning northern. Mm-hmm. And fun fact, I was at Australia Zoo the day before yesterday, and some of their animals are the boreal species. And I didn't realise we use that term in animals as well.
Oh,
I'd only seen it in Aurora Borealis.
Ah, okay. Yeah, there you go. I didn't know that either, except for Aurora Borealis. And I know that Borealis just kind of means north. So yeah, there you go, the northern crown. Yeah,
so animals just outside of the Arctic Circle, then there's kind of the boreal region, and animals from there are boreal.
Ah, there you go. I didn't know that. Well, the northern crown in the sky, the way you spot it is you look for, and it actually is one of the few constellations that looks kind of like what it's supposed to be. So unlike Sagittarius that looks like a spider's web, the Corona Borealis looks like a crown, not like a full crown that goes all the way round, but more like a half
tiara.
Crown. Yeah, like a tiara. Yeah. So the 7 stars in this roughly, it's not quite semicircular. It is almost tiara shaped. And the brightest one is called Alphecca, and it literally just means the bright one.
Nice.
Yeah. And so the mythology behind this constellation is it was a crown given by Dionysus, who defeated the Minotaur in ancient Greek legend, and he gave it to his partner Ariadne before he abandoned her. So, as with most of the stories about the stars, there's some love and then there's some tragedy, and everyone's an asshole.
I mean, at least it makes for a good story. What about Corona Australis? What's the story behind that?
Oh, I think they just like, well, if there's a northern crown, we may as well have a southern crown.
Some sailors came a few centuries ago and went, we've got a northern crown, there's a southern one, done.
Yeah, I think that is the story of Corona Australis. We'll have to make that the constellation of the month when it's up in a good viewing position.
Yep.
But the real reason I've made Corona Borealis the constellation of the month this month is because we're going to expect a new star to appear in that constellation soon.
What sort of things do they look for to know a new star's coming?
It's there one day and you look. It's not there one day when you look, and then it's there the next. There's suddenly a star
Well,
there.
then how do they expect there to be a new one? What do you mean? No, don't answer that so sarcastically. You said we're expecting a new star.
Yeah. No, I'm kind of misleading it by giving the word new star, but we're expecting what's called a nova to happen there, and nova does mean new, and it actually comes, and new. In the history of astronomy, nova has often been associated with new stars that just suddenly appear. What they are is there is a star there. It's called T Corona Borealis. And the letter T because they ran out of letters for naming all the other stars. They named them Alpha Corona Borealis, Beta Corona Borealis, and eventually they run out of Greek letters, so they start using English letters now. And so we're up to T, the letter T for T Corona Borealis, and it's a very, very, very faint star. It's far too faint to be seen with the human eye. But about every 80 years or so, it just suddenly has this massive eruption in brightness, and then it becomes 1,500 times brighter, and you can suddenly see it again. And we're expecting that to happen within the next month or two. So it might happen in August, it might happen in September. They're kind of excited. And by they, I mean the astronomers.
You as well, it seems.
Yeah, it is cool because it had this sort of flare up in 1946 and again in 1866, so about every 80 years. So you can do the maths.
So how long does it last? Like, do you have to be looking and then it just flashes, or is it like quite that whole night?
A few days is the sort of thing.
Okay, so we'd know and then we could be like, okay, go look at it tonight and you'd see it.
Yeah, exactly. Unfortunately, we don't know, you and me right now, so you'll have to just keep your eye on the news for when it suddenly astronomers announced new star appear in the north.
And then go outside that night and you
look.
should see it.
Yeah, exactly. Because it fades quite quickly. But what's really, and the reason is because what it is actually the surface of the star is kind of just exploding.
Yeah.
So what it is, it's actually two stars, a white dwarf star and a red giant star. So a white dwarf star is sort of a really old dead star that's kind of stopped fusing hydrogen. It's just kind of dead, and it's what the sun will look like in about 5 billion years' time. Meanwhile, a red giant star is, wind the clock back a bit, it's just before the star dies, it swells and goes red, and that's sort of the last gasp of a dying star. And what happens in this case is the white dwarf star pulls material off the swollen red giant star. It just pulls the material away because the red giant star is so big, its gravity can barely hold itself together, and all of that material accumulates on the white dwarf star. And then every 80 years or so, there's enough material that it can, just for a short period, it can flare up again and ignite, and that's called a nova. It just bursts out just for a few days because it's only got enough material to fuse like that for a few days, and that's what we see appearing in the sky.
Cool. Spaceflight Focus this month is exciting for us here at SciTech because, well, we're not going to do too much of it now. We're actually going to do a whole separate podcast because it's been mentioned in a media release now, so we can talk about it, that SciTech is getting the Polar Satellite Launch Vehicle fuel tank that washed up on the shores just up north of WA last year now. How long ago?
July 2023.
Yeah, yes. So I was actually reading a news article about it yesterday, and it said, after months and months of it being kept in storage, in limbo, we now finally know its destination. But it was decided quite a while ago that SciTech it hasn't been like in limbo for a year. We've known about it and we've been planning for it, and now we're just finally ready to actually put it on display. But yes. Yeah,
we didn't just get it.
Yeah, no.
But obviously with these things, you need to make sure you're preparing it properly. So that's what we've been quietly working on behind the scenes. And so, yes, we're releasing a completely separate podcast to this. So go and listen to that. It is still going to be a Please Look Up podcast. And we'll be dedicating all of that to the Polar Satellite Launch Vehicle debris that you would have seen in the news. So go and tune into that now.
Has anything gone wrong in space or flight this month?
The space fail of the month. Yes. I wanted to talk about a failure of policy.
Does this have anything to do with the email you sent the planetarium team going, have you guys heard about this?
This is exactly what I wanted to talk about. It's one of those things where you're like, it's so silly that you just kind of have to, that meme where like 50 people facepalm at once that goes into like every YouTube skit ever. Yep. That's what this is. It's the Viper. It's the NASA Viper moon rover is what it is. So if you haven't heard of the Viper Moon Rover, VIPER is an acronym. It stands for Volatiles Investigating Polar Exploration Rover. So it's a rover. It's designed to go to the moon, and it's to look for volatiles. And volatiles are things that aren't rock, basically. They're volatile. They tend to evaporate, which means they're not on the surface. You need to go and dig down to find them. And this particular rover was going to go to the south pole of the moon, and it was looking for evidence of water. So there's been a number of circumstantial pieces of evidence from orbiting satellites of the moon and other studies that have suggested that in some of the craters on the south pole of the moon that there could be water in the form of ice locked up in the rock, either as literally just solid ice or maybe just dispersed amongst the soil and things like that. And that's what it was going to be doing. It was going to be landing there and exploring, and that's exciting because if you're going to live on the moon, you need to have a source of water and energy and living. There's all sorts of problems with living on the moon, but if you can land on a crater that's got lots of water in it, you've solved one of those problems. So it's a very exciting mission.
Well, it was.
It was, yeah. Now the problem is
the problem is bureaucracy.
Bureaucracy, yeah. Death by bureaucracy. The problem is it's gone over budget, and
that sounds like NASA.
Yeah, it happens with NASA, and as there's parts of NASA's funding say that they can't go more than a certain amount of money over budget on a project, and this one is about to do that. It's about to go over budget, and as a result, they've had to cancel it. But there's another...
Sounds like a good policy in theory, to be like, you have to stick to budget or otherwise you don't get to do your project. Like, I get where it's coming from.
Yeah, absolutely. It does make sense. Yeah, you don't get a free ticket. The problem is that there, as part of the funding for the this rover, they've already bought and paid for the flight and the landing equipment. And that, by contract, has to go to the moon. And so as a result, because the rover has been cancelled, but the rest of the stuff has to go to the moon, they're going to put a mass simulator, just a block of concrete, on the rocket, on the lander, and send it to the moon because they can't send the rover.
Yeah, probably also worth mentioning in that the rover has been built. Like,
yeah,
the rest of the project was just like testing it out to make sure it would be all good to go. And so they've had to stop that part of the project because they can't afford to do that testing. But instead of actually sending the rover as the mass simulation, they're going to send a fake mass. You might as well just send the rover up and see how it goes up there. But no, not quite.
Exactly.
It's ready to go. We're not going to send it. We're going to send a fake mass instead. Which I think also... I know recently Beth was talking about space tourism and the environmental impact. So I think has a few people scratching their heads going, oh, another rocket we're sending for almost no reason. NASA will try and justify it. But when you think about those effects on the climate and such.
Yes, there's always that to consider. And the funny thing is, the reason it went over budget is because it's landing on something called the Griffin lander, built by a company called Astrobotic. And you might remember Astrobotic from a podcast several months ago, where they had attempted to land one of their landers on the moon, and it had failed on the way to the moon. It sprung a leak, the fuel tank sprung a leak, and the whole thing ended up burning up back in Earth's atmosphere. And as a result of that, NASA were understandably concerned before putting this rover on the lander. And so Astrobotic said, no, Rose, we're going to need another 12 months to really sort out this lander. And in that waiting 12 months, when you do that on the rover project, you still have to keep the rover in good condition for 12 months. And that is what's pushing it over budget. Yeah. So it's not even the rover itself that's gone over budget. It's the keeping it in operational condition while the lander gets, ready to land. It's bureaucracy gone mad. Yeah. If you're going to send the mass simulator, why not just send the rover?
Yeah.
So there is some silver lining. NASA has put out a call for industry. Does anyone want to come in and save this project with $20-50 million and get all the glory?
You got that line around to go save them?
No, I'm busy. Sorry. A lot of things.
I have the 20 mil. I just
it's hard work.
Probably won't get there.
Those applications were due. The closing date was today, so we'll find out. Today's the 1st of August. We're recording this, so we'll find out soon if NASA found a sponsor, or what they're going to do is they're going to disassemble the rover and then put all the actual scientific equipment onto future missions. But those future missions might not get there for another 5 years, by which time they might be obsolete. So it's bureaucracy gone mad.
Well, So that is
that's
quite
why
the
I'm
fail
calling
of
it
the
the
month.
space fail.
Yeah, I can say that.
It went from almost roaring success to space fail.
So next we're moving on to space picture of the month.
So this is the part we're well aware is just perfectly friendly for radio, where we will send each other, Amanda and I will send each other a picture that we have selected. And then what we're going to do is we'll describe the picture to you, and then Amanda will explain why she's chosen her picture, and I'll explain why I've chosen mine. So do you want to send me your picture first?
All right. This one is my photo. It's quite a famous photo in space.
Ah, interesting. Okay. This is... I haven't seen this photo for quite a while, actually.
You have seen it before?
Yeah, it's just been a very long time since I've looked at it. So what we're looking at is it's a photo taken from space, and it's taken from the moon. And so the bottom half of the photo shows the surface of the moon, and then the top half shows the black sky, and way off in the distance of the black sky is the Earth, and it's very small. It's very hard to see, but it is the Earth because it's the only thing that it could be. And also in the foreground is an Apollo landing module. And so you can see there's the moon. Sorry?
The eagle.
Oh, it's the eagle. It is, of course, the eagle.
If you've ever heard that call, the eagle has landed. That's that one.
It's the eagle. It's in the foreground. Yeah, it's an Apollo lunar landing module. So, yeah, you've got this dichotomy of dark sky, Earth in the background, and then in the foreground, the bright moon surface and the eagle, this lunar landing vessel. Tell us about this, Amanda.
So this was taken by Michael Collins. So he's up in the command module in orbit around the moon. So this is from the Apollo 11 mission. And so 3 astronauts went up on that mission to the moon, as you might know, but Michael Collins had to stay inside the command module while Buzz Aldrin and Neil Armstrong descend to the lunar surface in the Eagle. So that's what they're doing. So that's what that picture's showing you. So every single human is captured in that photo, whether they're on Earth or whether they're in that landing module, except Michael Collins, who's the man taking that photo. So it's sometimes referred to as the loneliest man. So it kind of shows how isolated he is up there. But yeah, I chose this one for a few reasons. I really love the Apollo missions just because what they represented historically for humanity in our interest in space. Like, humans have had a permanent presence in space for so far this century. So for the past couple of decades, there have always been people in space in the International Space Station. Mm-hmm. And so whenever kids come into the planetarium, I always talk to them about that. I'm like, your entire lifetime, there have been astronauts in space the whole time. And we just kind of have gotten used to that. And I had a conversation with my mother-in-law recently where she said she thought we'd already been to Mars. And I was like, no, that would be a very big thing. We haven't been to Mars. In fact, we haven't been back to the moon since the Apollo missions over 50 years ago. But I think we've sort of lost that really interest in space. And I just thought it was a great time of passion. Well, there were some other things going on globally that might not have been the best time. But in terms of space travel, there was just this massive buy-in from everyone. And everyone sat down and watched this moment. And it was a moment of coming together and being really, I think it was the best of America. We all mock America. We're like, oh yeah, America. But they're the only country that have put people on the moon. There is something to the American spirit. And it was a really positive thing I think you can take from that for humanity.
Yeah, wow. What a nice way of summarising it. It's funny you should mention, because I've had people ask me or tell me that they didn't realise that The Martian, the film, was not based on a true story. That someone wasn't left behind on Mars. It's interesting because you're right. Everyone knows the moon landing, and then have kind of assumed it was business as usual ever since, and we've just been carrying on to the moon and to Mars. And the moon is ages away. It was a massive deal thing that we made it there, and we haven't been back. And the other story I like about this, I don't know if it's true or not, but apparently...
Hold up.
Apparently a journalist asked Michael Collins, what were you thinking when you were, alone in the command module while Neil and Buzz were on the moon and everyone else was on Earth back at home? And apparently he said he was thinking that the spacecraft in which his life depended was built by the cheapest bidder.
A great quote if it's true.
Yeah,
I really love that you've gone, I don't know if it's real. It sort of reminds me of, in case anyone doesn't know, Leon's favourite scientist is, of course, Albert Einstein. And you see all those quotes from Albert Einstein around the place. I just like to quote them all the time. And I don't know if any of them are true. I like to believe they are.
The vast majority of them are not. But that's not going to stop you, is it?
No.
All right. Well, thank you for that picture, Amanda. It's a slice of history there for sure. All right. I'll show you. I'll send you my picture now. And it's a slice of history as well in its own unique way.
Cool. So I'm looking at a robot, but a robot that looks more like a rover than a human type robot, and it appears to be on the lunar surface with a starry background. You don't usually see the stars in the back of photos from the moon. That's okay. Is this Viper?
It is.
It does look very familiar. It's from things I've been reading.
It's what Viper would have, should have, could have been doing. So it is an artist's impression. It's not a photo. It is a picture.
This whole segment is a lie then.
It's called Space Picture of the Month.
Oh, is it?
Yes.
Oh, okay. All right, I'll allow it. It is a picture, I suppose.
So yes, it's an artist's impression of what Viper looks like or would look like on the surface of the moon. But I want to call your attention to the fact that it's a very boxy kind of rover.
That where all the money went?
Not really. But
it is quite boxy. It's not as elegant as the Martian rovers. I was just thinking when I saw this earlier.
Yeah, it looks like someone's stuck wheels onto a big cardboard box. It's very, and the reason for that is because of where it was intended to be driving, and that's near the South Pole, as I said. And just like on Earth, the South Pole of the Moon it doesn't receive much sunlight. The sun is always at a very, very shallow angle above the horizon, and so it never there's midday on the South Pole, the sun's, just barely a handspan above the horizon. So what that means is the sunlight doesn't come in from above, the sunlight comes in from the side. And so the sides of this Viper rover are where the solar panels are going to be, which is why they're so tall and vertical. So that's actually why it's to catch sunlight, because if you put the solar panels on the roof of the rover, you won't get any charge.
That makes sense. I hadn't thought of that.
And because of that, as well, it needs to be battery powered and recharge efficiently, because it's going to be exploring craters that, if you imagine the sunlight's coming in sideways, there are craters that go so far down that the sunlight just never gets to the bottom of the crater, even when the sun's at midday. And as a result, it's going to need its own independent power source when it goes completely in the dark.
There you go.
There you go. But,
so if you were wondering why we should fund the arts, it's because science won't get us here, but we have this artistic rendition, we could see what could have been.
It reminds me of a quote from Shades of Grey.
What? Oh, no.
No, just one, not 50, where the librarian is talking about the books, but they forgot to renew the license, and so all the books are gone.
All the books are gone, yeah. All the government's taken away, but I can remember where they're supposed to be.
I can tell you what books were supposed to be. That brings us on to our final segment of today, which is a Deep Sky Dictionary.
Deep Sky Dictionary.
I'm not sure I know how to answer that.
Yes, Amanda, I asked you to pick a word. Can you please define?
No, I've actually decided we're not going to do that.
Okay.
I've picked a word because it is my least favourite word in all of space.
Oh, no. I know what it is.
And you're going to tell us about it. Leon, do you know what this word is?
Is it nebula?
It's nebula. Something I have a deep-seated hatred for. So, Leon, how would you define nebula?
This is why I asked you to be here. This is the wildcard element of Amanda. Nebula. Well, and in this explanation, we'll get to the bottom of why Amanda doesn't like this word. So, nebula is an astronomy hangover, for lack of a better word. So in the days of, when astronomy was still in its infancy, when telescopes were just barely better than, today's scratched glasses and things like that, it was very hard to make out what was going on. We didn't have the vocabulary. We didn't even know what galaxies were or exploding stars. However, a lot of fuzzy blobs when you look at them through a telescope, tend to look kind of roundish or fluffy or blobby, or perhaps you might even describe them as nebulous. And as a result, the word nebula became a blanket term to describe anything that was kind of fuzzy and round and blobby that you could see in the sky. However, as science and astronomy has gotten more and more refined and technology has gotten better, we've been able to pick out that these fuzzy, blobby nebula are not all the same thing. There's many, many different things that were once classified as nebula. And so now when you're a student of astronomy trying to study what is a nebula, it's this wormhole of links within
Absolute nonsense is what we're going to call it. What's a nebula? Oh, it's this region of gas and they're forming stars. Also, it's when a star dies and it explodes. That can be a nebula too. Those are the completely different ends of a star's lifetime. What do you mean where it is being born and also where it dies are the same thing? I hate it so much. The only times I've ever talked about nebulas in my show is when sometimes I'll go out and ask an audience, what do you want to see in a show? And some kid will really want to see a nebula and I'll go, all right. And I'll have to put a nebula in my show for that kid. So if you've ever been there and asked to see a nebula, just know I did that out of love for you. But
there we go. So Amanda,
I hated
taking
it.
requests for nebulas. So to give some examples, you mentioned where stars are born. Mm-hmm. So many people have heard of the Orion Nebula. Yep. And so, one definition of a nebula is a huge cloud of gas and dust. And by huge cloud, we're talking light years, across hundreds of light years even. And the Orion Nebula is an example of that. It's a cloud of gas and dust which is slowly collapsing under its own weight. And as it does so, some overdense regions get more and more dense, and eventually they form stars.
Which we give the very adorable name Stellar Nursery. Great name. Adorable.
Yeah,
Love
Stellar
that.
Nursery.
Love that.
Yeah, but when you look at it through a telescope, it's kind of wispy and gassy and blobby and nebulous. So therefore it is a nebula. However, yes, you're right. At the end of their lives, remember we spoke about the red giant stars that swell up just before they die? Well, the dying moment of a star is it throws off those outer cool red layers and they expand and it becomes also called a nebula. However, this one is probably the worst one because it becomes called... Do you remember which type of nebula this is called?
Is this the planetary disk?
Yeah, it's called a planetary nebula.
Yeah, this is planetary nebula, which has nothing to do with planets. So even when we realised what they were, we still were misnaming them.
That's right. Yeah, planetary nebula. The name was given in the 19th century, and it stuck. But no, a planetary nebula has nothing to do with planets. It's the last gasp of a dying star as it throws off its outer layers, and because they're often round. Through telescopes, they look round, and so they thought they were planets, and so they called them planetary nebula.
Not to be confused with protoplanetary nebula.
No, because that is where planets are being formed.
Protoplanetary nebula is when there are so basically a star has formed, and then there's all this matter around it, and then that matter is forming planets.
Yes.
So I would accept that being called a planetary nebula, but
yeah,
no.
you would. So you've got that confusion based on what nebulas, they describe what they're doing. So planetary nebula is a dying star, a protoplanetary nebula is a forming planets, a stellar nursery is a nebula that's forming stars, but then there are also nebula that are defined by how they interact with light.
Yes,
so,
like a dark nebula.
Yes.
Dark nebula I can get behind, easy. Well, again,
what's a dark nebula?
Debatable about the word nebula, but if anyone's ever heard of the emu in the night sky, so that's something we talk about as an Australian Aboriginal story that's told. So within the Milky Way, if you're out looking at Scorpius and Sagittarius, if you can see the Milky Way, you will probably see a big emu in the night sky. And if you're trying to spot it, you can look for the Southern Cross, which will be on the emu's head. But that is a very dark patch within the Milky Way. It actually looks kind of empty. You'd think there's just not stars there, but there are. What that is a dark nebula. So it's mostly full of dust, just stuff that gets in the way of light passing through it. So that's why it's called a dark nebula, because light can't pass through it. So it looks like a dark patch in our night sky. That one adequately named. I am okay with that.
You're okay with that?
That one I'm all right with.
Okay, good.
It's actually several dark nebulas, the emu.
Yes, it is.
But all combined, looks like an emu.
Yeah, exactly. But then you've also got emission and reflection nebula, which emission nebula, they're kind of self-explanatory. They spontaneously give off light. They emit light. And reflection nebula, they reflect light. However, these terms are not exclusive. So, for example, in the Orion Nebula, where you've got stars forming, so it's a nebula, a stellar nursery, but then as those stars start to take shape and they start to shine, they give off lots of ultraviolet light, which stimulates the rest of the gas in the nebula and causes it to glow, so it becomes an emission nebula. But at the same time, some of that light from the star will reflect off the gas and it will become a reflection nebula at the same time. And if there's some more gas in the way, it'll be a dark nebula.
And if you're just trying to read the Wikipedia page on all of this, there's too many links to go down. It doesn't make any sense. And anyway, that's why I picked nebula for today. And hence why, as soon as I said my least favourite term in all of space, Leon knew exactly what I was talking about.
We'll just finish as well. Even what we now understand to be distant galaxies were sometimes called nebula as well.
Yeah.
So the Milky
Way...
Way...
they at least got renamed.
Yeah, they did get renamed, yeah. But yeah, sometimes you'll find really old text referring to the Andromeda Galaxy as the Andromeda Nebula for the same reason, that through an old, not very good telescope, they look nebulous.
Yeah. And we've had this argument a lot. But why are they still called nebula even though we know they are all different things? Why can't we change the name?
Yeah, I actually agree with you. I think we should. One of the interesting things about astronomy is some facets of it have been retrofitted for the olden terminology, nebula being one of them. My pet peeve is magnitudes, but we might save that for another day. Oh dear. Well, it's been a time and a half, but that's all we can cover for this month. Thank you for being here, Amanda.
Thank you for having me and explaining nebulas to everyone.
And thank you for listening, everybody. We'll see you next month when we talk about the night sky and the space news for September.
Bye.
If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.